Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 39 from the Smith Organic Chemistry textbook. This problem gives us two ball and stick models and asks us to give the IUPAC name for each of them and to draw the product formed when they're each treated with each of 5 reagent sets. Okay, and so the first thing to do here is to redraw these as line models. Ball and stick is hard to work with, so I would just redraw these as the skeletal structures. Okay, and so A is a 4-carbon chain ending in an aldehyde, so it's going to be butanal, and we have 2 methyl groups at carbon 3, and so this will be 3,3-dimethyl butanal. So 3,3-dimethyl butanal. Okay. And so when we treat A with sodium borohydride and methanol, we're going to get reduction of the aldehyde to an alcohol. So the product there will be this one. Okay. Next, if we use a Grignard reagent, we'll get addition of that methyl group. So alcohol here. And so I guess we should include stereochemistry here. So we can either get the methyl group here, which puts a hydrogen on the dash, and we can also get the other product where the hydrogen is wedged and the methyl group is dashed. Okay, for part 3, this is a Wittig reagent, and so we're going to do a Wittig reaction. So we will end up with this. Okay, and I've drawn the trans isomer. We would get some cis isomer as well. I'm just going to leave it as the trans. For part 4, this is going to be imine formation. Okay. All right. So then for part 5, we are going to form the acetal. And so that is going to look like this. Okay, and so that's everything to do with molecule A. Molecule B here on the next page. This is going to be named as a cyclohexane derivative, so it'll be cyclohexanone. And then if we number making the ketone carbon number 1 and give the substituents the lowest possible numbers, we get a methyl group at 2 and an isopropyl group at 5, and they are cis to one another. And so if we put that all together, we get cis 5 isopropyl, cis 5 isopropyl 2 methyl cyclohexanone. So cis 5 isopropyl 2 methyl cyclohexanone. Okay, so then if we treat this with sodium borohydride, we get a reduction of the ketone to an alcohol. And unfortunately, since there are other stereocenters in this molecule, we do have to account for whether that's going to be the cis alcohol or the trans alcohol. So we'll get both. So we'll get this molecule as well as this molecule. Okay, I am going to try to move that up so that I have some more room here. Okay, so for part 2, let's see if I can move this up a little. All right, so for part 2, we're going to get addition of a methyl group since it's a Grignard reagent, Grignard reaction. But again, we need to account for stereochemistry in the products. And so we will get the product where the methyl group has added on the same side as these other two substituents that are there already. And so our alcohol will be on the dash. And we will also get the other product where the methyl group is on the dash and the alcohol is on the wedge. Okay, so those are our two products there. For 3, again, this is the Wittig reagent, so we'll do a Wittig reaction. And so we end up with a double bond here. And so we can have the cis version or the trans version. And so we'll get a mixture. So cis as well as trans. Okay. So then on to part 4. Again, this is going to be enamine formation. Thankfully, there's only going to be one stereoisomer here. Okay. And then lastly, we're forming the acetal in part 5. I'm going to put this over here so that I have enough room. Okay, so we're forming the acetal, as I said. So 1, 2, and then we need to make a 6-membered ring out of this. So there we go. Okay, and so that's the whole answer here. It's kind of a lot. Again, the names of the two starting materials are written next to them at the top of each page, and then the products of each reaction. And for B, since we have stereochemistry in our starting material, we need to account for the different diastereomers that we can get from many of these reactions. And that's the answer to chapter 21, problem number 39.